Today we're going over one last theorem, and I am going to totally butcher the pronunciation, but you'll get a bunch of different ones if you look this up. DeMoivre's theorem, DeMoivre's, I'm not quite sure, he's French. But this is the last theorem we're going to go over for our test, and the theorem, I'm going to write the name again before I write the theorem. And before I forget, you will have to have this memorized for the test. And just like the multiplying polar numbers and dividing polar numbers theorem, you don't have to memorize the whole theorem to know how to use it. You just have to memorize the couple of operations that you need to do in order to do it properly. So again, when I say memorize, kind of take that with a grain of salt. So if we have a polar number, r cosine of theta plus I sine of theta So we have a typical polar number. If that is raised to an exponent n, then that is equal to, and then here are the operations. You take the r to the nth power, and then inside the polar number we have cosine of, inside you do theta times n. And you'll do that in both places. Plus I sine theta times n. So once again, all you do is you take the r to that power, like an exponent, but then you multiply it by the theta. As you can imagine, it's easy to remember, but some students will flip the rules. One of the most common mistakes I'll see is students will multiply r and n instead of doing the exponent. So again, it's just about keeping the operations straight, figuring out what to do where. That's it. All right, we'll do two examples. Oh, and before I do that, I always like to forget, just like with the multiplying and dividing rules, your theta must obey the condition. It's greater than or equal to 0, so it can be 0. But it is strictly less than 360 degrees. It cannot be 360 or higher, which in radians would be 2 pi or higher. So if you get 360 or you get 2 pi, you can't use those numbers. You're going to use 0 instead, because that's just 0 but repeated. Okay, now I will do an example. And I'm only going to do 2 of these. These are quite straightforward. Example 1. If we have, and when a problem starts with brackets, that's going to be your indicator. This is DeMoivre's theorem. 4 cosine of 70 degrees plus I sine of 70 degrees. Bracket raised to the 5th power. And then this is just basically 2 steps. So I'm going to set it up first. First you do r to the 5th, so 4 to the 5th. Parenthesis cosine of 70 times 5. Plus I sine of 70 times 5 again. And then you just do the math. 4 to the 5th is 1024. parenthesis cosine of 70 times 5, that's 350, which is still less than 360, so that's allowed, degrees, plus I sine of 350 degrees. There's our answer. So like I said, it's pretty straightforward. The only difficult part is we're not handing you the formula on the test, so you have to remember what the operations are. But aside from that, it's pretty easy to do. One more example. This one's going to be in radians, which I actually quite like radians in these. I think the math is actually a bit easier. Bless you. Example 2. Again, when you see a bracket, you already know it's DeMoivre's theorem. 2 cosine of pi over 3 plus I sine of pi over 3, brackets to the 4th power. And again, first I'm just going to set it up. We have 2 to the 4th. Remember, it's an exponent, not 2 times 4. Cosine of pi over 3 times 4 plus I sine of pi over 3 times 4. Two to the 4th, that's 16. Cosine. Now, whenever you're multiplying with the radians, we're going to give you whole numbers because their exponents are going to be whole numbers. So it's just going to go on top or multiply by whatever's on top. But if you want to put it in the calculator just to be sure, I'll do that one good time just as a reminder. When you type the radians into your calculator, you must drop off the pi. You can't plug pi into here or it will give you decimals automatically. So pi over 3, that's 1 over 3. So I do 1 over 3 times 4, and that's going to give me 4/3. And then when you get into larger fractions, it doesn't hurt to use the calculator anyway. That way it'll automatically reduce it for you. It will just make it faster. All right, so we have 4 pi over 3. And the other thing, when you put it back on your paper, don't forget the pi. The pi is important. Without the pi, it's no longer radians. I sine of 4 pi over 3. And hopefully you can tell that 4/3 is smaller than 2 pi, but remember you can always check that in your calculator. Whatever your fraction is, it must be less than 2 or else you have to subtract 2 pi, or just 2, so that it'll fit the condition. Otherwise, that's our final answer.